The Earth's atmosphere is more than 1 billion years old and way more interesting than we think. The answer you're looking for, it might be in this video.
Now let's talk about the importance of Earth's atmospheric pressure. And maybe let's stop ignoring how important this tire pressure sign is too. Stay safe out there. The pressure of the atmosphere decreases with altitude, but does not decrease linearly with altitude. The air molecules in the atmosphere are more crowded at sea level due to Earth's gravity, and the weight of the other air molecules above it causes the air molecules to be further compressed. There are more air molecules at sea level, which causes higher atmospheric pressure than at higher altitudes. The average weight at sea level for a column of air is approximately 14.7 pounds per square inch. Weight is determined by the mass and gravitational force on the object. Mass is the quantity of matter in the object, and is the same everywhere in the universe. Therefore, the average weight of air molecules on Earth will be different to other planets like Mars and Jupiter. The weight of all the air in Earth's atmosphere is 5,600 trillion tons. That's about the total weight of 32,000 Mount Everests. The weight of these air molecules will exert a force on our bodies, but the molecules inside our body also exert an equal force to the pressure of the atmosphere, which is why on a day-to-day basis we don't feel anything. At 5.5 kilometers above sea level, the air pressure is approximately 50% less than at sea level, and at 50 kilometers, the air pressure is 99% less than at sea level. Mount Everest has an air pressure of approximately 300 millibars at the top of the mountain, and commercial airplanes travel at an air pressure approximately 250 millibars.
The Earth's atmosphere is like an onion. It has layers. But understanding the atmospheric pressure of Earth is very integral to understand how the atmospheric layers are formed.
The troposphere is the lowest atmosphere on Earth, and also where we live, and all of my 20 and 30 aunts and uncles, and about 60 cousins. This is also where Mother Nature's weather occurs, such as twisting tornadoes, day after tomorrow type hurricanes, and rain, hail, sleet, thunderstorms. The tropospheric layer also is where commercial airplanes fly, and where people, jump out of airplanes. Comment below on your favorite weather condition. The height of the troposphere varies with latitude. The height of the troposphere is higher at the equator and lower at the poles. This is because sunlight is more concentrated at the equator, which warms the surface and the air above it, causing the warmer and less dense air to rise and expand. The troposphere can be approximately 20 kilometers at the equator and 7 kilometers at the pole. Think about holding a flashlight and pointing it perpendicular to the ground versus pointing the flashlight at an angle to the ground. The intensity of the light is greater and more concentrated where the energy source is directly above an object. This just happens on Earth too. The sun is higher in the sky for a longer period of time at the equator. Therefore, it receives more solar energy than the other latitudes throughout the year. The air temperature in the troposphere decreases with altitude at approximately 6.5 degrees Celsius per 1,000 meters. This is also called the environmental lapse rate. At approximately 11 kilometers altitude, air temperature stops decreasing and becomes constant. And this area is also called the tropopause. The tropopause is at the top of the troposphere, but the height also varies with latitude for the same reasons as explained earlier for the troposphere. It also has approximately 75 to 80% of all the air mass of the atmosphere, which mostly consists of oxygen and nitrogen. Nitrogen is approximately 70% of the atmosphere, and oxygen is approximately 21% of the atmosphere.
If you want to see part 2 of the atmospheric layers, about the stratosphere, mesosphere, thermosphere, and exosphere, please see this video up here.